see your answers on my other computer. Let me just make me a co-host. Yes. And so just change your chat features. Oh, it only says everybody. Okay, perfect. Not a problem. Perfect. Thank you guys. So I'm going to share my screen and we are going to get started. I need you to open up the slideshow for today and let's get started. Share the screen. Yes. Let me come to the pathways lesson. I need you guys on slide number 2, and I need you to take 1 minute right now, 1 minute only, to decide which one of these glasses holds the most amount of water, which one holds the least amount of water. I just need the letter in this box right here. You're taking 1 minute right now. This is our warm up for the day. Awesome, awesome. I'm just going to make a copy of this so that I can type in it because I am at home. You are still working on yours. C3. Awesome. You're taking another 30 seconds to look at those 3 containers, those 3 glass containers, and decide which one's holding the most amount of water, which one is holding the least amount of water. I want you just trying your best. This is literally just a guess. There's not really any scientific way that you can prove right now without watching the video how much is in here. Oh, Billy is here. Did I let him in and not notice it? Weird. Okay, wonderful. Let me close this out here and let's get started. Okay, so we're looking at this guy here. Which container holds the most amount of water? Which one holds the least amount of water? Now we're going to prove it. Let me let this person in. Okay, and let's watch this video going through which one has the most amount of water, which one has the least amount of water. So what this video is going to do, I want you to be prepared, is it's going to take this mason jar and it's going to empty it out and it's going to pour the other 2 in to compare it. So let's take a look at, I want to draw attention to a few things as we're watching this video. Okay, so first, I want you to notice that the mason jar is filled all the way to the tippy top line. It's all the way up to the tippy top, okay? So let's look here. Let's see what happens. We're going to empty out that mason jar, and we're going to pour in that short jar. Okay, I'm going to pause it for a second. In the chat, let me know. That's okay, Annie, you can just follow along. So looking at this right now, this tall, skinny one, does it hold more water or less water than the mason jar? More or less than the mason jar? Awesome. Yes, it holds less. Very good. Nice job. Let's take a look at the little curvy Q guy, the curvy guy. Okay. So let's I'm going to pause it just so, oh, no, guess I'm not. Let me go back here. So if we look at how much this curvy Q guy has, and if we remember that the mason jar was filled all the way up to the tippy toppy, which one holds more, the curvy one or the mason jar? Does it hold less or more? Very good. Not the curvy, Carter, the curvy. Yes, that was awesome, Carter. Kirby. No, alas, I'm not talking about Super Mario Bros. I'm talking about curvy, like curvy. Okay, anyways. So which one ended up holding the most amount of water? Which letter ended up holding the most amount of water?
A.
Yes, nice job. That was perfect. A ended up holding the most amount of water. Which one ended up holding the least amount of water?
B.
B, yes, very nice job. B held the least amount of water. Awesome job there, my friends. Let's take a look at our learning targets for today. One of them is not how we usually write learning targets. Our learning targets are usually sort of more broad and not as specific. But the second one here is actually a very specific learning target where we're saying I can write an equation for the relationship between the total volume in a graduated cylinder and the number of objects added to the graduated cylinder. That's our second one. Our first one is we're going to use patterns to write linear equations to represent a situation. So really, in essence, what we're going to be doing today is we're going to be writing equations for some different situations that we're going to be dealing with. Okay? So let's take a look at this first activity that I want us to work on for today. So what I want you to do for today is I want you to grab, for when you're working, I want you to right now drag your, actually no. For right now, I want you to just be in your Zoom. So when you're in your Zoom, let me just see this one that just joined us and let me let her back in. I believe I already marked her down. She sort of fell off the list. It's okay. So what we're going to be doing is I'm going to be opening up this tool right here on slide number. Up. Let me click on my link. And I'm going to scroll down to the activity for today. So what we're going to be doing is we have a graduated cylinder. That's just a fancy word for like a glass or something that holds water. And if we look at this graduated cylinder, when we have 0 marbles in our water, how many milliliters is our water level? So when we have 0 marbles in our water, what's our water level here? How many milliliters is in our container? I think I froze. Did I freeze? No? Okay. Yes, nice job, Bridget. It is 60. Awesome job, Avery. Courtney, yes. Bridget, fantastic. Avery, fantastic. When we have 0 marbles in our water, we're going to have 60 milliliters. So in your slideshow, on slide number 6, when we have 0 objects in here, we're going to have a volume of 60 milliliters. Okay. So if we look at and we add some marbles to this container, let's add some marbles. Let's add 1. When we have 1 marble in our water, how much is our water level now? Nice job, Sawyer. Nice job, Avery. Nice job, Annie. Fantastic job, Courtney and Olivia. Yes, when we add 1 marble to our water level, when we have 1 marble in there, our water level is 63. So every time, this is a question now, every time I add 1 marble to my water, how many milliliters does it add?
3.
Nice job. And Bridget, let's see why it's not 65. So where we're looking here, if you're looking at the Zoom here, Bridge, it says the number of marbles is this first row, and then the water level. I don't want you to look on the actual graduated cylinder for the water level. It's written right here because it's a little bit tricky because it's not that big of a graduated cylinder. So the lines are really close to one another. Does that make sense, Bridge? Awesome. Okay, I see you shaking your head. Perfect. So every time we add 1 marble to it, Diego said it adds 3 milliliters. So did Annie, so did Courtney, so did Avery, so did Carter, so did Jaden. So let's prove it to ourselves. Let's add, so in this table, we said one had 63. Let's add one more marble to our tank and let's see what happens. So 2 marbles has 60. Nice, Diego. So now 2 marbles has a water level of 66 centimeters. So let's add that to our table here. 2 marbles has a water level of 66 milliliters. Now, am I wrong, Carter? Is that what you're trying to say? Okay. Oh, you got it. Okay. You're doing great. So now I want you to take a little bit of, it's going to be a little bit of a trickster. I want you to try to calculate how many, what's our volume going to be when we have 5 marbles in our container. I don't get what you're trying to say, Diego. I want us to do 5 here. How many milliliters would we have if we have 5 marbles in our, nice job, Jaden Ramos. Nice job, Courtney. So we're taking another 30 seconds to decide if I have 5 marbles in my water, how many milliliters is it going to take up? Awesome job, Carter. Awesome job, Bridget. Nice job. And if you want to just send it to me privately, you can change it to everyone. You can change it to Miss Germaine, MISS Germaine, and then it'll send it to me privately if you want to change it like Bridget did. Nice job, Bridge. Awesome. So let's see. Let's prove it. Jaden said 75, Bridget said 75, Carter said 75. Let's prove it using this app here. So now let's add another marble. We're going to said 75. Jaden was the first friend that said 75. Jaden, do you want to unmute and can you tell us how you got that 75? It's okay, Carter. Well, I'm frozen. Am I frozen? Nice. So he added 3 more marbles. So he took that 66, he added 3 more to figure out how much 3 marbles would have. So 3 marbles would have 69. Add 3 more to that would be 72. And then add 1 more group of 3 to that and it would be 75. Nice job. I freeze sometimes. I'm sorry about that, you guys. I'm trying my best here. What's going on, Diego?
It's like every time you freeze like 30 seconds. So like usually if you're going over something, it's like you freeze and like you're on to like the next problem. It's kind of like meh.
Okay, so I'll try. Let me know in the chat when that happens, and then I can try to stop what I'm talking about. Okay. Yep. So now I want you to try one more challenge question. I want you to try to figure out how much 10 marbles would have in the cylinder. I want you to take 1 minute right now to figure out how many milliliters 10 marbles would have. Nice job, Jaden. Nice job, Courtney. Nice job, Bridget. Nice job, Carter, Annie, Kaylee B, Avery, Courtney, very good. Olivia, very good. Nice job, Isabella and Gabby. We're taking another 20 seconds to figure out how many milliliters 10 marbles would have. A lot of friends are saying 90 milliliters. Let's use that tool, that website, to help us to figure out how many marbles it would, or how many milliliters it would have. So if I add another marble here, it would go to, I think I just froze again. If I add another marble, we're at 7 marbles. It would be 81. If we go to 9 marbles, it would be at, or 8 marbles would be at 84 milliliters. 9 marbles would be at 87 milliliters. And 10 marbles, look at that, would be at 90 milliliters. Awesome job. You guys were right. Awesome job, guys. So we got that guy correct. Nice one there. So that was question number 1. Now we're going to move on to question number 2. Question number 2 says, what is the volume V in the cylinder after you add X objects? Explain your reasoning. So I'm going to come in here and I'm going to type out something that's going to help us. For this right here, we need to write an equation that would go with this scenario, right? And remember, we always write equations in the form of y is equal to mx plus b, where m is our constant rate of change. How much are we adding every time we add a marble? And b is that y-intercept, or that vertical intercept. How much did we start with in our tank of water? That is that question that it's asking us when we're looking at that b there. Okay, so if I'm trying to write an equation for this, I know that it's going to start with this letter y is equal to, and what did we say was our constant rate of change, or how much are we adding every single time we add a marble?
3.
Nice job, Diego. Interesting, Jaden. Well, let's think about that 6 though. So we're talking about our constant rate of changes. Every time we add 1 marble, it adds 3 milliliters to our volume. So our rate of change is going to be 3, because every time we add a marble, we add 3. So our rate of change is going to be 3x plus, how much did we start with in our graduated cylinder? Oh, no problem. Not a problem, Jaden. You're doing great, my friend. How much did we start with in the cylinder at the beginning? Nice job, Avery. Wonderful, wonderful. I'm seeing some answers here, my friends, and I'm seeing some similar answers here. Yes, we're starting with 60. So our equation is going to be y, or our total volume. Our total volume of water, our water level, is equal to 3 times the number of marbles you add plus the original 60 that you started with. Okay? So that's going to give us our total volume of our cylinder, is when we get our total volume of our cylinder by multiplying 3 times the number of marbles, and then to that we're going to add that original 60 milliliters that we started with. Okay, so if we want to make the water reach the highest mark on the cylinder, how many objects are we going to need to add? Let's take a look at our cylinder. So does 10 marbles take us all the way to the top of our graduated cylinder here? Thank you, Diego, but that's not the question that I'm asking. The question that I'm asking is, does the 10 marbles take us all the way to the top of our cylinder? And no, it doesn't. So let's see what happens when I add another marble here. When I add another marble, am I at the top of my cylinder yet? Am I at 100 milliliters yet? No, I'm not. So let's add another one. Let's see what happens. If I have 12 marbles, does it take me all the way to the top? No, it doesn't. Nice job, Olivia. No, it doesn't. So let's add one more marble. I think it, oh, let's see what happens. Oh my goodness. Are we all the way at the top? I love what Jaden said. Jaden said, it's one off. Oh my goodness. Let's see what happens. Let's add one more and see what happens to it. Oh my goodness. So how many marbles? It's overflowing, exactly, Avery. So how many marbles do I need to add for it to overflow? Ooh, but Courtney, remember when we had only 13, it reached that 99. We want to say how many marbles will make it overflow. So 13 marbles isn't going to work. Can we add half a marble, Avery? No, we can't add half a marble. So we can't say 13.5 because I don't have a saw that would like cut a marble in half. Like that's risky business. So we're going to say how many marbles is it going to take to overflow? It's going to take us 14 marbles to make it overflow. So how many marbles is it going to take? It's going to take 14 marbles to make it overflow. Okay? Nice job, my friends. Let's take a look at this graph piece here, okay? So raising water levels, slide number 7, okay? So it says plot and label points that show your measurements from the experiment. So we need to use these points down here to plot some of these data points that we found here. So if I want to plot this first row here, 0 and 60, I'm going to go over to what number? I'm going to go over.
Can you get a chance? Can you go back to this? Yeah, that slide, please.
The table slide.
Yeah, the one we're on right now, because you froze.
Oh, I froze.
Like
Okay.
Well, you didn't freeze, but like my Zoom did.
Okay, so we're using these data points right here. I'm going to go back in a second to plot some points on our grid here. So we're going to go over on the number of objects, the x-axis. We're going to go over to 0, up to 60, and we're going to put a point. So that means if I'm looking at this graph right here, I'm going to grab one of my points off this stack. I'm going to go over to 0, up to 60. And I'm going to put a point right here. On my other computer, I just lost internet. So let's try that again. Let me pull up the chat on my other computer. Sorry, guys. Questions can go in the chat there. I can still see them. Were you guys able to plot your point at 0, 60? Let me know in the chat, or if I can see your face, you can just sort of shake your head. Nice job, Lily. Nice job, Carter. Wonderful. So we have this point plotted at 0, 60. Ooh, these are kind of tricky. So it might be, if we look at this table, what might be an easy point to plot when our number of objects is what number? What might be an easy one to plot here? Yes, Ethan. So Diego, I'll show you how to do it in a second. So we plotted the 0, 60. Yes, Avery. So another really easy one to plot might be this 10, 90. So that means I need to go over to 10 and up to 90 and plot a point. Diego, I'm going to show you how to plot those points, okay? So if we come back to slide number 7, you're going to grab one of these points off the pile, Diego. So watch. Okay, so you grab a point off this pile, Diego, you go over and up to 60 and you drop it. And we're going to plot one at 0 or 10, 90. So we're going to go over to 10, up to 90. 90 is halfway between 80 and 100. And so we have a point here and we have a point here. When I have 2 points on a graph, what can I do to those 2 points? I can connect them, right? And create a line. Diego, were you able to plot those points? I just went out again. Sorry on my other computer, guys.
I'm doing it right now.
Perfect. Okay. So I'm going to pull this chat up because it's just not working on my other computer. So I have 0, I have my chat open here. I know you guys can see it. That's okay. And I'm going to connect those points. So you're going to grab this pink line from down at the bottom. You're going to line it up with your your y-intercept right here. You're going to grab the end and pull it until it goes through that point that you plotted, just like we did with our rulers when we were in class. What do you mean it's steeper, Avery?
Like it doesn't start at 0, 0.
Exactly. It doesn't start at 0, 0. It's not a proportional relationship. Yes, Avery, it's not a proportional relationship. Very good. Nice job. So we need to compute our slope. But do we actually even need to compute our slope, or do we know what our slope or rate of change is? Do we know? What's our rate of change, guys? How much do we add every time we add a marble? Nice job. Awesome job. Yes. So our slope, we don't even need to compute it in these boxes right here. We can just write it. Our slope is 3 milliliters per marble. So every marble that we put in there, it adds 3 milliliters to our total. Awesome job. And what is our vertical intercept? Where does this line hit our y or vertical axis? Nice job, Avery. Very good, Jane. That was really specific. I love that. That was great. Nice job. I think you meant to write 60, Carter. Try one more time. Yes, perfect. So our y-intercept, or our vertical intercept, is where does it hit our y-axis? Where does our equation line hit our y-axis? It hits it at, if we're writing it as an ordered pair, it hits it at 0, 60. And what does it represent in our story? It represents the amount of water we started with. In our graduated cylinder. Okay. Awesome, awesome job, my friends. Very, very good. So we have about 2 more minutes of class right now. We're going to have about officially 1 more, and then I'm going to go 1 minute over. Let's take a look at slide number 8. Okay. So on slide number 8, we're not going to do this first one right here. First, we're going to look at this one right here, and I want you to write this variable y instead of that variable v. So that variable y, what did it represent in our story? If we think about, what did that y represent in our story? The volume, yes. Yes, Avery. The v represented the total volume of water. Very good. The total volume of the water. And x represented the number of what? Nice job, Avery. The number of marbles that we added. Very good. Very good. The number of marbles that we added to this cylinder. Okay, so we talked about what that rate of change was on the last slide and what that 60 represented on this last slide as well. So we don't need to do these 2 boxes right here. So if you look at slide number 10, you see that word cohort 3. If you click on that video, it should take you to an Edpuzzle video for the second half activity you're going to be working on for today. It's a little bit tricky. We're trying our best. We're doing the best that we can, okay? So you're going to click on that cohort 3 video, and you're going to follow along, pulling your video to one half of your screen, your slideshow to the other half of your screen, and you're going to work alongside the video. I don't have you, so number 10, you're going to do in the video. I actually do number 10 in that video. I just put this slide in the wrong spot. is really what happened.
Can you go back to slide 7 when you get the chance?
Yes. So on slide number 10 for you, you have that the cohort videos. You're going to click on your cohorts video. You're going to watch and you're going to email me if you have any questions. Like I said, it's a little bit tricky, but you're just going to try your best. Okay.
Do we do slide 9?
Yes, so slide 9 I actually do in the video. I put this slide in here in the wrong spot on yours. Like I put it in the wrong order. The order got mixed up. Okay. Is everyone clear on what you need to do this afternoon? Awesome. Perfect. So if you have questions for me, you're sending me emails. And I will see you all tomorrow. Okay. Awesome. Bye, guys. I'll see you all tomorrow. I'm so proud of you guys for your hard work. Wait, I'm going to stop.
Bye.
Bye, guys. The windshield wipers. Bye, Kyle. Bye, guys. Bye, Kaylee B.